Hello, and in this video we're going to be looking at geometric sequences. I've given you three examples of a geometric sequence in this first slide. My examples are 4, 12, 36, 108, 5, 10, 20, 40, 80, and 100, 50, 25, 12.5, and 6.25. Now, a common thing that you're looking for in a geometric sequence is a common multiple. These you multiply by 3 each time we move up to the next number. This one we're multiplying by 2 each time we move up to the next number. So it has a common multiple from one term to the next. This one we're multiplying by 1/2, 1/2, 1/2, or dividing by 2, but we're multiplying by a common number each time we move down the sequence. That number is called the ratio. We can denote it R for the ratio of the geometric sequence, and we're going to look at how we can determine the geometric sequence from that ratio. So geometric sequences have the same ratio throughout its terms. So if we check a sequence to see if it's geometric, what we would do is write out the first few terms. Let's say on this one we're going to start with 1 for the first term, and 2, and so on. If n is 1 here, we have 4 times 1 minus 1, that's 0. So that's going to be 5 to the 0 power, which is 1. So our first term is 4. Our second term would be 2 minus 1, which is first power. First power of 5 is 5 times 4 is 20. Third term is 25 here, because it's 5 squared. 25 times 4. 25 times 4 is 100. Okay, and then the next one would be 25. Let's do one more. N is 4. So it would be 125, because n being 4 would be 4 minus 1, which is 3. 5 to the third power is 125. And then we multiply that by 4 and we get 500. So if we're looking at this, we can see the terms. We're going to look at the term differences or ratios here. We're multiplying by 5. We can check this by doing 20 divided by 4, and we get 5. We get 100 divided by 20, we get 5. And if we did 500 divided by 100, we get 5. So each one of these terms is a multiple of the previous term by a multiple of 5. So this one is yes. It is a geometric sequence because it has a common ratio between its terms. All right. Now we're going to write that general formula. We're going to define a general formula between the sequence when we use a sub 1 as the first term and r is our ratio. So here's our ratio is r. And we define the first term as a sub 1. That's our first term. Now our second term would be to take your a sub 1 and times it by r. Our second term would be to take the previous term, which is a sub 1, or this would be a sub 2, sorry, a sub 2. We take the previous term a sub 2 and times it by r. It's a sub 3. A sub 4 is a sub 3 times r, and a sub n. We're trying to generalize the formula. Now usually what I would do here, just as the previous one we did it for arithmetic, I would substitute for this a sub 2. We know a sub 2 is a sub 1 times r, so this is a sub 1 times r, which is a sub 1 r squared. Now a sub 4 is going to be a sub, we're going to take this one now and substitute. So it's going to be a sub 1 r squared times r. We're substituting this one in here for that. So we're going to get a sub r1, a sub 1 r to the third power, and then so forth. We should see that this is going to be an a sub 1, the first term, times the ratio, and the ratio is going to have a power on it that's 1 less than the term number. If you look at this one's 3, this term is 4, it's 1 less, this term is 3, this power is 2, so it's 1 less, so we're going to write that n minus 1 power. So this is going to be our general nth term formula for any geometric sequence. So we're going to use that. So in this case we have, this was the previous one where we had the ratio being 3 each time. Each time we go through this, we went by 3 each time, times 3, times 3. So r in this case is 3. Now a sub 1 is our first term, which is 4. So our answer for this, a sub n, equals 4 times 3 to the n minus 1 power. That's our a sub n formula for this example. Now on our second example, this one was our, we were multiplying by a half each time. So r is a half on this problem. So our answer to an a sub 1 here is 100. So our a sub n term is 100 times 1/2 to the n minus 1 power. Okay, and that's our answer for this sequence. That'll give us any term in the sequence. All right, and we may specifically want a specific term. If we want a specific term, then we're going to use this formula and evaluate for that term. So here's my example for in that purpose. If I want the 15th term, my first process would be to find the a sub n term. So I want to find a sub n first, and then use the formula with n equals 15. So that's what I'm going to do to solve this problem. So in this problem, by looking at the terms, I'm multiplying by 2 each time. So r is 2, and a sub 1 is equal to 5. So my formula, a sub n, is 5 times 2 to the n minus 1 power. Okay, and then I would use that formula to find a sub 15, which is 5 times 2 to the 15 minus 1 power, which is 5 times 2 to the 14th power, which is, let's just compute that out and see what that is. Okay, and when computing this out, it would be 2, okay, make sure it works, 5 times 2 to the 14th power. So we get 81,920. So 81,920 is our solution. That's the 15th term of that sequence. We wouldn't want to write this out 15 terms to figure that out. So this is a good thing that we have this formula. All right, our next example here is whether we can determine whether the sequence is arithmetic, geometric, or neither. This will be our final thing from this section. Last section we did arithmetic. This one we did geometric, and there are also some sequences that don't fit into those two categories. So when you're looking at determining whether they're arithmetic, geometric, or neither, you want to look at the terms. I always look at the terms, and arithmetic means there's a common difference, which we call D, and the geometric, we have a common ratio, which is R. Okay, common ratio, which is R. And this one was D. Okay, so when I'm doing this, I'm just going to fill in some numbers here. So I'm going to start with n is 1. So 1 here, that would be 2. N would be 2. That's 2 to the 4th, which is 16. Then n is 3, so that's going to be 3 to the 3rd times 2. That's going to be 54. And then n is 4, so that'd be 4 to the 3rd times 2 is 128. Okay, I can see here that there is no common difference here. If you look at these and we subtract this pair, we get 14. If we subtract this pair, we don't get 14. So we're going to get 38 for that difference. So there's no common difference, so it's not arithmetic. And if I were to divide to see if there's a ratio, 16 over 2 is equal to 8. 54 over 16 is not 8, I don't believe. 54 divided by 16 is 3.375, which is not, they're not the no common ratio. So this one is a neither. It doesn't have a common difference and it doesn't have a common ratio. So it's a neither on the first example. Now on the second one, it doesn't look like there's a common difference. Let's look at that. 18 minus a negative 6, that's going to be 24. And if we take negative 54 minus 18, we get a negative number, negative 72. So there's no common difference. So it's not arithmetic. Now let's look at the ratios here. So we take 18 divided by negative 6, we get negative 3. We take negative 54 divided by 18, we get negative 3. We take 162 divided by negative 54. Okay, let's try that. 162 divided by negative 54, we get negative 3. So it looks like there's a common ratio here. So the common ratio happens. So this tells me that it's geometric. And finally, let's look at this final example here. I'll write out some terms for this. If n is 1, then I'm going to get 3. If n is 2, I'm going to get 1. If n is 3, that's 6. 5 minus 6 is negative 1. N is 4. 4 times that's 8. That's negative 3. 5. That's 10. So it's negative 5. Alright, and so on and so forth. Just putting in n equals 1 through n equals 5. I get these terms. Alright, now I always check the difference first, so I do 1 minus 3, I get negative 2. I go negative 1 minus 1, I get negative 2. I go negative 3 minus a negative 1, I get negative 2. So it looks like there's a common difference here, and the common difference is negative 2, and we see that up here, right here. So this is arithmetic. Now when you look at formulas in our things here, you can see arithmetic is more like linear. So arithmetic, linear. Geometric is more like exponential. So this one's an exponential formula. So if you're looking at formulas in your arithmetic sequences, if you see an exponential function, it's probably going to be geometric, and if you see a linear, it's probably going to be arithmetic.